This is part 1 of the Chapter 8 lecture on climate change. And so climate change is hopefully a household, household terminology by now. The world has accepted climate change. The United States is one of the only developed countries that has not accepted that climate change is happening due to human causes. The administration, the Trump administration completely outright denies. In fact, Scott Pruitt, who is now in charge of the EPA, he doesn't believe in climate change. President Trump doesn't believe in climate change. So we have a lot of issues with the acceptance that climate change is real and that it is affecting humans. But most other countries in the world have accepted that climate change is happening and that there are dire consequences, that if we don't stop our CO2 emissions, we're going to increase the temperature of the earth, which then causes major problems, which then causes global warming and changes our climate throughout the world. So here are just some examples of climate change. Of course, one of the biggest deals is the melting of the ice caps. And what happens is remember, once those ice caps melt, they add fresh water to salt water, which they change the salinity of the oceans. When they change the salinity of the oceans, they change those ocean current patterns. And when those ocean currents pattern, they change the world's climate. So this is a big problem. The Earth's atmosphere is warming. We have, on record, have had the hottest temperatures in major cities throughout the United States over the past 5 years, and they continually increase. And this is a big issue. Permafrost in the Arctic has melted, and this is a big deal in the summers because a lot of times we drill, and this is a good example. The permafrost, or the permanently frozen ground, has melted beneath the foundation of houses, and this has caused railroad tracks to become unaligned, and for houses to fall, because what happens is in a lot of these areas they actually drilled into the permafrost because it was like a concrete layer, and structures were built using that as the foundation. But now that this permafrost layer is melting, of course it shifts those. So big problems throughout the world. But you know, a lot of people believe that climate change is a natural pattern, and it is a natural pattern. The problem is that it hasn't, the changes that we have seen throughout history haven't happened in such a dramatic pace as they have happened recently because of added CO2 emissions. So the Earth's climate, yes, is dynamic, and it has changed over the past millions of years. Over the past 10,000 years, the Earth has grown warmer with ups and downs trends. Over the past 1,000 years, we have seen warming event and then cooling event, etc. But it doesn't mean that what's happening now is normal. So I'm going to walk you through the ages. About 2 million years ago, the global climate began to display cycles of colder and warmer temperatures. Each one of these cycles of cold and warm lasts usually about 100,000 years. Scientists call this time of alternating cold and warm periods what we call the Pliocene age, or epoch. The cold periods between 8,000 years ago brought unprecedented glaciation, and so this is what we call the glaciation period. Okay, so huge glaciers between 1,000 and 3,000 meters thick spread across the areas of North America and Eurasia, and during warm periods the glaciers retreated or disappeared entirely. Later cold periods or ice ages again produced glaciers, and the most recent continental glaciation lasted from about 110,000 years to 12,000 years ago. At the peak of the last ice age, glaciers covered 30% of the Earth's inland, and this is what created the Great Lakes and other areas in the United States. And so the Pliocene age was an age of glaciation. Then the last 10,000 years of the Pliocene age is what we call the Holocene age, epoch, And during this, the Earth has begun to warm, and it's what we call an interglaciation period, meaning in between glacier periods. Even so, global temperatures have varied. Climates were especially warm between 9,000 and 5,000 years ago, and this period correlates closely with the variations in the Earth's orbits that favored solar heating. Average temperatures became a bit cooler. And in the past 1,000 years, though, we've also witnessed significant climate variation. Climatologists call the years from AD 1000 to AD 1300 the medieval warm period. So during this time, the average global temperatures have increased by 0.5 degrees Celsius. So over time, we had these glaciation periods, then we have these interglaciation periods where the Earth gets warmer, and we're able to farm, and we're able to support ourselves through agriculture. Now there is this little blip on the map called the Little Ice Age, and this continued into the 1700s and the beginning of the Industrial Revolution. Actually, Europe was hit really hard with this Little Ice Age, and a lot of the areas in Europe couldn't farm during this time. And I'm just going to quickly show you, this is where during the peak of the glaciation period 20,000 years ago, you can see the glaciers moved all the way down pretty far into the United States. And then remember, when these retreated back, they brought with them, they dug out a lot of lakes in the United States. They left behind a lot of glacial rocks, etc. Okay? But you can see here, the recent climate change, though, is what we're worried about. The Earth has significantly warmed since the Industrial Revolution, and it's difficult to measure global annual surface air temperature, so we have to use models and sampling station and examine temperature anomalies, etc. But what we have found is that we have definitely increased the global temperature of the Earth significantly since the Industrial Revolution. And if you look here, you can see here since the Industrial Revolution, the Earth has been getting warmer. Could the Industrial Revolution release of air pollution into the atmosphere and warming have a link? And this has been based on data from thousands of locations. And you can see that the 5-year mean and the annual mean. So this is the temperature and this is the year. And you can see here that they have kind of correlated with each other. Okay, and so this is a big deal. This shows you since the 1800s we have seen an increase in temperatures. And these are the anomalies, all the outliers. But the causes of natural, so, we have some things that we need to talk about and worry about in terms of climate change. Now, there are natural causes in climate change, and here are the list of reasons for that. Number one, the natural causes of climate change are regional variation in annual temperatures. And of course they vary. Land, of course, heats up really fast and releases heat really fast. Oceans take a really long time to heat up, and they hold their temperature for a long time. There's also the El Nino and the El Niña, and these are southern oscillations in those, remember those ocean current patterns I showed you, those surface ocean current patterns? And they alter the weather patterns. But there's also volcanic eruptions, and when we have seen volcanic eruptions happen throughout history, like the Pompeii, we have seen Mount Vesuvius, we've seen other major volcanic eruptions. What happens is they release a lot of ash into the atmosphere. They block the sunlight from coming through, and we have seen cooling periods. So yes, these are all natural variations in temperature, but what we have seen recently is just not natural. So the Earth's atmosphere can be affected by a couple things. The amount of solar radiation coming through, the Earth's orbit, so how we rotate and revolve on our axis, and of course human influences. So chemical composition of the troposphere is the biggest thing that we have to worry about here, and that is carbon dioxide, methane, and nitrous oxide. These are what we call greenhouse gases. Now there's a couple other greenhouse gases as well that we should talk about, and they are CO2, So we have carbon dioxide, we have methane, we have nitrous oxides, and then we also have water vapor and methane and nitrous oxides. All of these are what we call the greenhouse effect. So what is the greenhouse effect? Well, the greenhouse effect is that these pollutants are in the troposphere, and what happens is they trap heat at the surface. So they form what we call a blanket at the Earth's atmosphere, which allows UV radiation as well as heat radiation through. But what happens is that heat radiation, a lot of that is usually re-radiated back out into space again. When we form this blanket with pollutants, once that radiation gets inside the atmosphere, it can't get back out again because it forms, the pollutants form that blanket. So then what happens is the Earth is forced to absorb that heat. And when the Earth's forced to absorb that heat, the oceans get warmer and Earth's land temperatures get warmer. Now, notice I haven't said anything about climate yet. This is how global warming happens. Global warming happens when the temperatures of the oceans as well as the temperatures of the land increase. Okay? Now they then change. Once the global warming happens, it changes the climate. So then climate change is a result of global warming. When global warming happens, remember the Earth's, let's say the ocean temperatures get warmer, then they melt the glaciers. The glaciers then, of course, change the salinity of the oceans, which then change the ocean current patterns. And when the ocean current patterns change, our climates change. So the result of global warming is climate change. And these greenhouse gases are a big problem. So if we could reduce these greenhouse gases, we would stop trapping so much heat at the Earth's surface. And then we would allow this heat to re-radiate back out to space again and not cause the problems that we have today. Of course, human impacts. We release these greenhouse gases through a bunch of stuff. Number one, we drive cars. We deforestate. Remember that the plants actually suck CO2 out of the atmosphere. So when we start deforesting and taking trees down, guess what? We are taking out the way that CO2 can be sucked from the atmosphere. So planting more trees does help reduce CO2 emissions. And we just talked about global warming, which is a major problem. And here you can see the CO2 emissions have increased, right? So as CO2 emissions increase, okay, you can see also since 1960 to 2010, we have increased our CO2 emissions significantly, which is a huge, huge problem. And as we have increased our CO2 emissions, we've also increased our nitrous oxide and our methane production, which is a big problem. And what we can see is if we overlay those CO2 emissions with temperature, we'll see they correlate together. So as we talked about before, what are the sources of those greenhouse gases that cause the greenhouse effect? CO2 emissions are the biggest thing. So burning of fossil fuels, industrial processes, and of course it widely varies from country to country, but the U.S. is one of the biggest producers of CO2 emissions. Here is just a wonderful little graph that shows you the anthropogenic greenhouse gas emissions in use. You can see power stations, industry, agriculture, fossil fuel production, and retrieval processes, residential sources, land use and biomass, and waste disposal. These are all anthropocentric. Now I want you to take a look at this. The annual CO2 emissions. So who has the highest annual CO2 emissions? China and the United States are the leading producers of CO2 emissions if you look at this graph or map. One thing you have to remember, though, is China has triple the population of the United States. So China and the U.S. have the most CO2 emissions, but if we had the same population as China, we would definitely out-pollute them. Remember, China has 3 times the population of the United States, and so we are definitely polluting way more. And the reason we pollute way more is because we have more consumption patterns than any other country in the world. So what are the consequences of global warming, which then correlates to climate change? Well, of course, climate patterns are changing. Some areas are going to get drier, other areas are going to get wetter. The glaciers are going to melt. It will, of course, show us more land masses, which could be an issue. And of course, there's going to be rising sea levels. I'm going to stop